Okay, let's jump right into this explainer by imagining a truly wild scenario. What if tomorrow morning you woke up with the power to control gravity itself? Imagine lifting entire buildings without touching them, walking effortlessly into the sky, or making massive objects float as if they weighed absolutely nothing. At first, this discovery would revolutionize transportation, construction, medicine, and even space travel. It would allow humanity to build floating cities, launch spacecraft without rockets, and explore distant planets like never before. It would seem as though humans had finally mastered one of the universe's most fundamental, unmastered forces. To figure out if this could ever become our reality, here's how we're breaking things down today. First, the mystery of gravity. Second, how we simulate it in space. Third, can we actually control it? And fourth, the physical limits of that control. We really have to ask this crucial question right up front to separate our wildest sci-fi fantasies from grounded scientific reality. What if we could actually control the last unmastered force of nature? Well, let's look at the science. Section 1. The Mystery of Gravity. Consider physicist Eric Verlinde's mind-bending concept of emergent gravity. He compares gravity to a cup of hot coffee. The temperature of your coffee isn't a property of one single microscopic molecule, right? It's an emergent, macroscopic effect of millions of tiny, unseen molecules moving around and interacting. Verlinde suggests that gravity, space, and even time might operate the exact same way. They don't exist as basic forces on a microscopic scale, but instead just sort of emerge from underlying quantum information. So, look at this idea here. Space itself might be built from this vast web of entangled information bits. If the microscopic state of all these connected bits has a high energy, the space we see on a large scale acts in a very specific way. And you know what? This provides a totally fascinating potential explanation for dark energy, that mysterious invisible force that's actually causing our universe's expansion to accelerate. Now, conversely, while some physicists look to those emergent properties, others are aggressively hunting for something called the graviton. This is a hypothetical elementary particle that literally transmits the physical force of gravity. Finding the graviton would be an absolute game changer. It could finally bridge that seemingly impossible gap between Einstein's general relativity, which governs massive stars, and quantum mechanics, which governs tiny atoms. As we can see illustrated here, researchers are currently running intense experiments to test if gravity propagates at a finite speed between two quantum masses. Basically, they're trying to prove if a physical mediator, like the graviton, actually exists in the real world rather than gravity just being this instantaneous, spooky action at a distance. All right, moving on to Section 2, simulating gravity in space. So, because we can't fundamentally control gravity yet, we have to look at how we're forced to fake it. The crucial point here is that current microgravity countermeasures, like strapping astronauts to bungee treadmills, simply aren't enough for long, multi-year missions to Mars. Without gravity, astronauts suffer severe bone density loss, and fluids drift right up into their heads, causing really dangerous intracranial pressure. Because of this, simulated artificial gravity is no longer just a cool sci-fi concept. It's an absolute medical necessity for our survival off-world. Check out these incredible NASA designs for making that happen. On the left is the bimodal engine, a spacecraft designed to naturally rotate around its center of mass to create a steady centrifugal force pushing outwards. And on the right, we have the Armstrong model, which uses these deployable, flexible solar wings to generate that exact same spin, but in a much more modular, cost-efficient way. But there's another truly fascinating concept called the linear sled. See, spinning an entire spaceship can cause intense dizziness and nausea for the crew, something known as the Coriolis effect. The linear sled completely avoids this by accelerating astronauts back and forth on a long, straight track. It accelerates them forward, flips their orientation, and decelerates them, using linear momentum to perfectly simulate the downward pull of gravity. Which brings us to Section 3. Can we control gravity? And really quickly, before we continue, if you're enjoying these mind-bending future scenarios, make sure to like this video, share it with a friend, and subscribe to Last Human Era for more incredible journeys into the future. Okay, so first we have to debunk the internet's absolute favorite illusion. You've probably seen those viral claims of gyroscopes magically lifting themselves and acting as anti-gravity devices. Honestly, these out-of-plane forces are completely illusory and totally unproven under controlled testing. Instead, we have to focus on legitimate physics derived from Einstein's equivalence principle, which links mass, energy, and electromagnetic fields to the actual curvature of spacetime.
Mathematician Andrei Fusfa proposes some exact steps to artificially create gravity. He theorizes that if we take massive superconducting electromagnets, like the ones they use at the Large Hadron Collider, and generate incredibly intense controlled magnetic fields, the sheer energy of those fields would literally bend spacetime. We could then use highly sensitive interferometers to detect that newly created, albeit incredibly weak, artificial gravitational field.
Now, as Fusfa himself notes, turning gravity on and off at will has always been strictly left to science fiction. Building his device would be wildly expensive, and it's currently untested. But proving it works, that could revolutionize our world. Imagine gravity-based telecommunications. You could literally call the other side of the world using gravitational waves that pass straight through the core of the Earth, completely bypassing the need for satellites. No more dead zones. Think back to that opening scenario we talked about. If we could harness gravitons on a massive scale, it would fundamentally transform human infrastructure. We could create vehicles that travel with zero friction, dramatically cutting emissions. We could build revolutionary gravity-based power plants to store and release energy, and massively enhance tidal energy generation. Let's ground ourselves a bit with Section 4, the limits of control. An exhaustive ESA-funded study looked at the hard physics of all this and, unfortunately, shattered our sci-fi dreams. It concluded that even if we successfully manipulated gravity, it wouldn't magically grant us Star Trek warp drives. The scientific reality is that our gains in terms of spacecraft propulsion would actually be pretty modest, and the energy required to manipulate these fields would be absolutely massive.
8.9 kilometers per second. This number right here represents the sheer delta V, that's the change in velocity, required just to escape Earth and reach low Earth orbit. It is a staggering mathematical hurdle that no amount of simple gravity manipulation can completely erase.
The Tsiolkovsky equation, shown here, calculates velocity and propellant mass, and it proves exactly why this is so hard. The ESA study showed that even if you could magically turn off an object's gravitational weight, you still have to deal with its inertial mass. Orbital mechanics dictate that centrifugal forces still require immense conventional rocket thrust just to keep a satellite moving fast enough to maintain its orbit. Basically, gravity isn't the only force holding us back. Inertia is a huge hurdle too. So, what about gravito-electromagnetism? Well, while we could theoretically use a gravitational analog of the Lorentz force to generate a torque, essentially pushing against Earth's own gravitational field for propulsion, the output is terribly weak. The harsh reality is that our current electrodynamic space tethers produce vastly higher thrusts than any hypothetical gravity drive ever could. As we wrap up this explainer, we have to remember that science itself is not good or bad. It's about who's using it for what. But what happens when such incredible power falls into the wrong hands? As gravity control technology spreads across the world, governments and powerful organizations could compete to weaponize it. Entire cities might be lifted into the sky, oceans could shift unexpectedly, and even Earth's orbit could be affected if gravity were manipulated on a massive scale. Scientists would face an even greater mystery. If gravity can be controlled, what other hidden laws of the universe are waiting to be unlocked? Humanity could stand on the edge of becoming an interstellar civilization, but one mistake could reshape the entire planet forever. And if these future possibilities fascinate you, don't forget to like this video, share it with someone who loves science, and subscribe to Last Human Era, because every week we explore the most unbelievable futures humanity may face. In the end, controlling gravity wouldn't just change how we move. It would redefine civilization, science, and our place in the universe. But if you had the power to control gravity for just one day, how would you use it? And would humanity